In a perfect world, SEC separates proteins by size alone. In reality, proteins can be sticky. These nonspecific interactions are a major hurdle in method development. Today, we'll learn how to detect these issues and optimize our conditions to fix them. If your protein is interacting chemically with the stationary phase, the peaks will tell the story. First, tailing peaks. A drag out back into the peak with tailing factor greater than 1.5 suggests the protein is sticking and slowly unsticking as it moves down the column. If your protein is interacting chemically with the stationary phase, the peaks will tell the story. Finally, check your recovery. In a perfect SEC method, doubling the amount of protein injected should exactly double the peak area without changing the retention time. If you see those red flags, we need to find out why it's sticking and then fix it. One common reason is ionic interaction. Think of this like magnets. If your protein is positive and the resin is negative, they'll attract. To test this, we perform the salt shift experiment. We run the sample at low salt, then again at high salt, around 200 to 300 millimeters sodium chloride. If the peak shape improves or the protein elutes faster with more salt, you confirm the issue. The salt ions act as a shield to block that electrical attraction. From there, you simply continue optimizing to find the perfect salt concentration where the protein no longer sticks. If salt doesn't work, then there might be hydrophobic interactions. This happens when greasy patches on the protein stick to the backbone of the column. For this test, we add a tiny bit of organic solvent, like 5 to 10% isopropanol or acetonitrile or 200 millimeters arginine, to the liquid. If the protein comes out earlier or the peak gets bigger, it proves the protein was being delayed by that greasy stickiness. To wrap up, non-specific interaction is a major hurdle in SEC method. As you develop your methods, always keep an eye out for those tailing peaks, late elution times, and bad recovery. By using the salt shift or organic modifiers or arginine, you can detect these issues and most importantly fix them so your protein can move freely.